Hi class. Today we will learn the first lesson of the subject English for the thermal engineering. This semester I will teach you this subject, and as you know, that is because of the coronavirus. So the university asked us to teach the lesson online, and this is the first lesson of the subject, and hopefully you will enjoy it. Okay, so what this subject will help you? The subject will provide students with the specialized terminology in English, as well as to provide their knowledge, their very basic communication and reading. So it means in this course I try to use communication. You know, the communication will be combined the listening and the speaking. So through the lecture, you will try to learn the lesson in English. That means to improve your listening skill. And you have to do the speaking a lot in the class in order to improve your communication skill. And also another object of this course will be improve your reading and reading comprehension skills. It means you will have to read a lot and translate into Vietnamese and English. And for the thermal engineering, two very basic, and I can say it's the most important subjects, that is the thermodynamics and the heat transfer. So in this course I will try to teach you again, because I know that you already learned thermodynamics and heat transfer in Vietnamese. So this subject is to repeat the subjects in English. So I hope that you will learn it easier, because you already learned once in Vietnamese. Also we'll use the principle of thermodynamics and the heat transfer to explain the thermal engineering applications. For example, you will know about the thermal power plant, about the refrigeration and air conditioning system, about the dryers and boilers, about the heat exchanger, about sustainable energy. And again, all these subjects you already learn in Vietnamese. So this course only to review the very basic and general knowledge of these subjects in English only. There are total 9 chapters in this course. Today you learn the first lesson. It is the basic concept, and you go through it after chapter 9. After that, you have to do the presentation and a lot of practice in the class. And for the reference book, there's a couple of books, but basically I will use these 4 books in the course. The first book is a Sangan and Boyce Thermodynamics and Engineering Approach. The second, also from Sangan, is Heat Transfer Practical Approach. The third book is related to the Energy Management book. And in order to help you to understand more clearly, you can use the Vietnamese book. That means the book of the Professor Hoàng Đình Tín. That's you already learned in the class. Okay, so now we go into the first lesson. That is the basic concepts. Before the lesson, I would like to list all the terminology and all the vocabulary that first to help you to understand more clearly when I start teaching the lesson in English. And I also want you to read it, to pronounce single words very careful. One of the reasons why most of the people cannot speak English because they cannot listen. And the problem is they pronounce wrongly, they speak wrongly, so when they listen they don't understand. So please tell me the terminology and learn it, and read it, pronounce it correctly. Okay, now class, listen to me carefully and repeat after me each single word. Okay, first, thermodynamics. Thermodynamics. Thermodynamic system. Thermodynamic system. Closed system. Closed system. Open system. Open system. Thermally isolated system. Thermally isolated system. Isolated system. Isolated system. Boundary. Boundary. Surrounding. Surrounding. Substance. Substance. Hot sauce. Hot sauce. Causing. Causing. Property. Property. State. State. Absolute pressure. Absolute pressure. Specific volume. Specific volume. Specific heat. Specific heat. Internal energy. Internal energy. Internal combustion engine. Internal combustion engine. Refrigeration. Refrigeration. Process. Process. Process path. Process path. Cycle. Cycle. Heat. Heat. Work. Work. Ideal gas. Ideal gas. Molecules occupy negligible space. Molecules occupy negligible space. Real gas. Real gas. Low pressure. High temperature. Low pressure and high temperature. Low pressure and high temperature. Gas mixture. Gas mixture. Specific heat. Specific heat. Internal energy. Internal energy. Internal combustion engine. Internal combustion engine. Refrigeration. Okay, go down. Okay, anyway, repeat. Process. Process path. Cycle. Heat. Work. Ideal gas. Molecules occupy negligible space. Real gas. Low pressure and high temperature. Gas mixture. Thermometer. Thermometer. Resistant thermometer. Resistant thermometer. Thermocouple. Thermocouple. barometer, barometer, vacuum meter, vacuum meter, pressure gauge, pressure gauge, kinetic energy, kinetic energy, potential energy, potential energy, isothermal process, isothermal process, isobaric process, isobaric process, isochoric process, isochoric process, isometric process, isometric process, reversible, reversible, irreversible, irreversible. Okay, now we go into the lesson beginning. Now we will go into the today's lesson. It is the basic concept. There will be four main parts in this lesson. The first, you will learn about the thermodynamics and the thermodynamic system. The second part will be the properties of substances. Third part, it is state, processes, and the cycle. And the last one will be the heat and work. All right, what is the thermodynamics? The thermodynamics, as you can see here, is a branch of physics concerned with the heat and the temperature. When you say heat, you can imagine that it's something hot or cold that is related to the heat. And the temperature, of course, the temperature is to measure the heat or to measure the place, to see that place or that object is hot or cold, so you give the temperature to measure it. All right. So thermodynamics is the physics concerned with the heat and temperature, and they're related to the heat, the energy, and the work. For example, you can see this one is the motorbike. You know it well. You use it every day, and to be able to run the motorbike, first you have to fill with the petrol, or we call the gas, put into the motorbike. That means you provide the heat, all right? And then when you provide the heat will be transferred to the work. That is the energy that moves the motorbike forward and bring you around the city. So the motorbike is related to the energy or the heat and the work, and it means the motorbike is the subject of thermodynamics. Another example, that is the air conditioner. As you know that in order to keep the room cool, you need to remove the heat from the room. And in order to do that, you need the air conditioner. So the air conditioner, you need to use the electricity. The electricity here will provide work for the air conditioner, and then that work will transfer heat from the lower temperature to the higher temperature place. As you know, you already learned in the heat transfer subject. We have the room here, and you can see that, for example, we got the room here, and you stay in the room. And normally, like in Ho Chi Minh City, the outside temperature will about 32 to 35 degrees, and it means very hot. Why our body will feel very comfortable when the temperature in the room is about 25 to 27 degrees. And you learned in the subject heat transfer, you know that the heat will be continuing go into the room because the outside temperature is higher than the inside temperature. So the heat will continuing going to the room. So in order to keep the room at the temperature 25 to 27 degrees, you need to put the air conditioner here, right? Okay, so you can say that this air conditioner will help you to move back the heat from the room to the outside. Or it means you move the temperature from the lower temperature place to the higher temperature place. So in order that you have to use the work, it means the mechanical work or electricity to provide the work. And then the work will help you to transfer the heat from the low temperature of the room to the outside place, have a higher temperature. Okay, that is about thermodynamics. So the objective of the thermodynamics is to determine the properties and energy of the system as well as the energy change of the system. The two examples of the motorbike and the air conditioners I just explained to you. That is the object of the thermodynamics. Okay, we look at the example. For example, when we boil water. So when you boil the water here, it means you provide the heat to the water. The water we put inside the pot here, and then the water become hotter and hotter, and by the end the water will be boiled, and it will change the phase from the liquid phase to the vapor phase. So it means in this case we provide the energy, and this energy will help to change the phase of the water. So it means this one of the objective of the thermodynamics. Another example, when you boil the water and the water become the steam, this steam will go into the steam turbine and run the steam turbine. For example, in the thermal power station, we provide the steam, and the steam run the steam turbine, and the steam turbine will run the generator to produce electricity. So you can see that this one is another example of the thermodynamics. That means we transfer the heat, we provide the heat, and the heat will transfer into the work that will help to run the generator. Another example, okay? For example, we got the turbine here, as I just mentioned. When we provide the steam for the turbine run and is provide the work, and this work help to run the generator to produce electricity. So this one, you can see this is the object of the subject thermodynamics. All right, the next one, what is the thermodynamic system? So the thermodynamic system, what is it? It is a region defined by the boundaries of the particular natures, together with the physical surroundings of that region, which determine the processes that allow to affect the interior of the region, studied using the principle of the thermodynamics. You can see in this picture, we got a system here. That is the thermodynamic system. And outside the system, it is the surrounding. Okay? And To separate between the system and the surrounding, we got the boundary. So the boundary can be the physical appear or just unphysical appear. That means this can exist or not exist in the real. Alright, so it means when you're talking about a thermodynamic system, you have to know about the substance. So I've talked too much. Okay, the substance, for example, should be the water, should be the petrol, should be the gas in the air conditioner. Later on you will know about that. So when you talk about the thermodynamics, you need to know the substance inside the system, the hot source and the cold sink. It means, for example, in this case, air conditioner here is the thermodynamic system. Okay, the thermodynamic system. Inside the room, this is the cold sink because it has lower temperature. And the outside of the room, that is the hot source. Okay, so it means the thermodynamic system have to put into the two separate place or the two source of the temperature. The low temperature one we call the cold sink, and the high temperature one we call the hot source. And the heat and work transfer when the working substance change its state. Later on we will know more about that. So it means besides substance, hot source, cold sink, the thermodynamics work with the heat and work. It receive heat, provide work, or it receive work to provide heat. Alright, and the boundary, as we just mentioned, the boundary is between the system and the surrounding. So it means when we talk about the thermodynamic system, we have to find out all these elements to be able to know exactly the thermodynamic system. Example, the hot coffee cup. Okay, so the hot coffee cup here, you can say the hot coffee in the cup, this is the substance. Alright, and the cup here is the boundary, okay, and the cool environment around the cup, say example it have the temperature of 20 degrees, this is the surrounding. Okay, so in this case the substance is the hot coffee. The hot sauce is it inside the cup, have the high temperature. The cold sink is its surrounding environment with lower temperature. Okay, and of course in this case the cup itself, it is the boundary, and in this case we don't provide or it not use work, but we got the heat transfer from the hot coffee to the environment around it, so we got the heat around. So in this case the hot coffee cup, it is the thermodynamic system. Okay, the second example, this is the internal combustion engine. You know that the motorbike you use every day, they use the internal combustion engine. Alright, so in this case you will know that we provide we provide petrol, and the petrol is mixed with the air and we burn it. So in this case the mixture of the air and the petrol, it is a substance. And of course, you know that when it works, the engine is hot. So inside the combustion engine, it is the hot source. And the environment surrounding the engine, it is the atmosphere, the environment with lower temperature, it is the cold sink. Okay, and in this case, we provide heat. I mean, when you burn the mixture of the petrol and the air, it provides heat. And when it's received heat, the engine will, produce work. So in this case, we got the heat and the work. And the boundary, of course, the boundary in this case, that is the engine itself. So that is, so of course, in this case, we can say the internal combustion engine, it is the thermodynamics system. Next one. For example, we are the power station, or we call it electrical power plant. For example, in this case, we use coal to burn coal to provide heat, or to be exact, the coal will burn the water inside the generator, or we call the steam generator, to provide steam. And then the steam will go into the turbine, run the turbine, and the turbine will run the generator to produce the electricity. Okay, so in this case, we can say that, of course, it is the steam generator, and it is the hot source. The outside temperature, or the environment surrounding system, it is the cold sink. And the substance, in this case, it is the steam itself. And we provide heat and produce work, that means it's run the generator to produce electricity. So we got heat, we got work, we got hot source, we got the substance, we got a cold sink. And the boundary, of course, that is the system itself. So again, the electrical power plant, in this case, it is thermodynamics system. Alright, that is about the thermodynamic system. So the thermodynamic system are classified into different systems. We call the closed system, open system, thermally isolated system, or isolated system. So what is the closed system? The closed system. The closed system is that no substance may be transferred in or out the system boundary. Okay, you know the substance, right? The substance is the materials inside the system. So if the substance cannot transfer in or out the system boundary, in this case we got the closed system. For the open system, of course, closed, it means substance cannot transfer, and the open, it is the substance may flow in or out the system boundary. The thermally isolated system, you can see here, the isolated, the isolated, that means you separate something out of other things, that means they cannot be contact. So the thermally isolated system, that means no heat is exchanged with its environment or with the surrounding. So the thermally is only the heat cannot transfer. But when we say about the isolated system, that means it does not interact with its surrounding in any way. Mass or energy cannot be transferred. Okay, look at the example of a closed system. So we just say the closed system, it means the system that the substance cannot transfer in or out the boundary. The example of the air conditioner, it is an example of the closed system. Later on, when you learn in the subject, in the lesson refrigeration cycles, you will learn more. But here I just say that inside the air conditioner, we got the gas, or normally we call the freon. For example, freon 22, freon 134A. That is the gas inside the system. So for air conditioner, the gas just run inside the system. It not transfer in or out of the system. So in this case, you can say that the air conditioner or the refrigeration system in general is a closed system because the substance inside the system cannot be transferred in or out the boundary. Next, how about the example of the open system? Come back to the example of motorbike. In motorbike, you provide the gas, and the mixture of gas and air is burned out and provide exhausted gas, or we call the smoke, go out of the engine. So in this case, you see that the substance of the system, it transfers in or out of the boundary. Or we can say that is the contact between the substance and in the system and the surrounding. So in motorbike case, we have the open system. Another example of the water heater. So we provide heat to heat up the water, to provide the hot water, and then the hot water you use for example, you use for a bath, or you use for cleaning or for cooking. So it means the water, you put the cold water in the system and you get the hot water out of the system. So in this case, the substance, it is water itself, it go in and out the system. So in this case, it is the open system. How about the isolated system? Look at the picture. Now, we put the water in a tank, a bottle, and we burn, or we provide a heat to heat up the water here. But the water here and all the equipment here, we put in the isolated box. And this box, we put the insulator in order the heat cannot go in and out. So in this case, look at this picture, and you can see that this is the system. They got the heat provided. We got the substance, in this case it is the water. But this system itself is isolated with the surrounding. So in this case, we got the isolated system. Okay? So that is about the thermodynamic system. And the thermodynamic system can be classified as a closed system or the open system. And depend on is be interact with the surrounding, the heat itself, or the heat at a mass. We call the isolated system or the thermally isolated system. Now we go to the second part. That is the properties of the substance. You know that in the thermodynamic system, we got the substance. The substance, that is the materials inside the system to receive the heat to provide work, or is receive work to generate heat. Okay? And now we have to look at the property of the substance. At any specific condition, the state of the substance can be determined as two independent properties. Later on we will know about the state, but in this one we will learn about the properties. the property, okay? So the property in the thermodynamics, we got different property. The first one is the temperature. You know about temperature, right? Pressure, okay? Pressure, you know, okay? Temperature is defined by T, pressure by P. The specific volume, we use the small v, okay? Remember the small v, okay? Not the capital V. The capital V is the volume. And the volume itself is not the property. Only specific volume is the property. Internal energy, we use the U to define it, and enthalpy we use H, and the last one is the entropy is the S. And in this case, temperature, pressure, and the specific volume we call the three basic properties. And these three properties can be measured. You know, you can measure the temperature, you can measure the pressure, and for the specific volume, you measure the weight, you measure the volume, and then you can work out the specific volume. So these three properties we call the three basic one, and it's measurable. Whereas the three other one, it is the internal energy, enthalpy, and entropy. It is the three calculated properties. That means we cannot measure internal energy. We cannot measure the enthalpy. We cannot measure the entropy. We only can calculate it. All right? It means in order to know the state of the substance, we need two independent properties. You will know about it later. For example, in order to provide the state of a substance, we will use the diagram here. And this diagram is constructed by two independent properties. For example, in this case, you can see that we use the property pressure P and the specific volume V to make the diagram. And then, as we just learned before, in order to know the state of a substance, we need two independent properties. So in this case, for example, we know the pressure P and the volume V of a substance. We will know the state of the substance. For example, we use the piston here just to press the air into the piston. The initial state, or we call the state 1, that means when we start the experiment, we got the initial state, and initial state will be defined at one point here, and it will be determined by the two properties. That is the V1 and the P1. All right? And after that, we press the air in the cylinder, and it becomes the state 2, or we call the final state. The final state here at the state 2, and is determined by the point 2. And the point 2 will be determined by the two parameters. It is a V2 and the P2. So it means we got the two independent properties in order to know the state of a substance. So here you will learn about the state, okay? The state, and when it moves from state 1 to state 2, we call the process, okay? And the way go into the state 1 to state 2, we call the process path, Later on, we will talk about that later. But in this picture, I want you to know that first is a diagram. The diagram will be constructed by two independent property. And normally in thermodynamics, we got different diagram. Okay, for example, the PV diagram. So in this case, we use two independent properties, is P and V. Another example that we also usually use is a TS. That means we use the temperature T and the entropy S to make the diagram. Another example, for example, we use P and the H. That means we use the pressure P and the enthalpy H to make the diagram. And each point in this diagram, we have one state. Okay? For example, we got state 1. It's figured by the point 1 there. And we got two independent property, is the V1 and the P1. Similarly, in the PS diagram, the point 1 will be determined by the entropy S and the temperature 1. Or in the pH diagram, we got point 1 is the state 1 determined by two independent properties, that is the H1 and the P1. Okay, so you see this, we got different kind of the diagram, and the diagram will be constructed by two independent properties. So it means each point in this diagram, it gives us a state of a substance. All right. Now we go into each property. This one maybe we go quickly because we know pretty well. Sorry, the picture is a little bit mixed, but you got this slides on the e-learning. You can download it. So the temperature to measure a warm or the coldness of the object or the substance with the reference to some standard value. Okay, so it means the temperature. So for example, your body normally they use your body at the normal temperature is 37 degrees. So it means when your body is 37 degrees is a normal. So the standard value of the body temperature is the 37 degrees Celsius. Okay? So when your body is or when the temperature of your body is more than 37 degrees, so in that case you got the cold, you got hot, or we call the fever. Okay, it means they use the standard of the temperature value standard at 37 degrees at the standard, and it means when your body have the higher that temperature, your body you got the fever or you got the hot, and of course when your body is lower this temperature is abnormal. Okay, for example, when you die, the temperature will go down into the zero, not 37 degrees anymore. Okay. So the temperature measure we using the thermometer. So the thermometer is the equipment to measure the temperature. So for the thermometer, we got the mercury thermometer or we got the alcohol thermometer. For example, we got a thermometer. I try to keep, don't worry, I just erase it. Normally the thermometer is like this, okay? And the top we just cover by the silver in order to contact to the place or the object that you want to measure the temperature. And inside here we can put the mercury, or you can put the alcohol here. And normally it's for example, if you put the alcohol, it will have the red color. If you put the mercury, it got a silver color. All right, and of course in this one they will mark the temperature, and when this point is contact to the place or the object that you want to measure the temperature, it will measure the temperature, and the alcohol or the mercury will go up or down in order to measure the temperature. So this one we call the mercury alcohol thermometer. Okay, the next one is we call the resistance thermometer. Is you use a temperature. You know that when the temperature of the resistance change, it will just expand or it will be contract. So in this case, you can measure the temperature by we call the resistance thermometer. Or the thermocouple. So the thermocouple, we use two different kind of metals, and when it's contact with the temperature, the different kinds of the metal will be expanded in different way. So in this case, we also can measure the temperature. And in the unit, there will be three main units to measure the temperature. We call the Celsius degrees, figured by C. The Fahrenheit degree is F, normally used in the British unit system, and the Kelvin, or we call the absolute temperature, we call the K. And remember, for the degree Celsius, we got the 0 here, we call the degree. Same with Fahrenheit, we got the degree here, but for the Kelvin, we don't use a degree, okay? And this formula help you just to work out the different temperature. For example, in the case you know the Fahrenheit degree, you want to know about the Celsius. So the Celsius degree will be equal to 1/9 of the Fahrenheit degrees minus 32 degrees. And this formula will help you to transfer the Celsius degrees into the Fahrenheit degree. And of course, this formula will help you to transfer, to work out the Kelvin degree from the Celsius degree. And this one is a comparison between the three temperature scale. We got the Kelvin here, we got the Celsius here, we got the Fahrenheit here. This is the temperature that you need to remember. For the Celsius, you know, the water will be solid, we call the frozen, change from the liquid phase into the solid phase at the 0 degree, at the normal atmosphere. Huh? And when we bring up to the 100 degrees Celsius, the water boil. It means it start transfer from the liquid phase into the steam or the vapor phase. But in the Fahrenheit degree, the water will be start solid or transfer the phase at the 32 degree Fahrenheit, and it will be boiled at the 212 degree Fahrenheit. So it's different between the Celsius degree and the Fahrenheit degree. And in the Kelvin system, you know, at the 0 Celsius degree is equivalent to 273 Kelvin. And at the 0 Kelvin, 0 K, equivalent to minus 273.15 degrees Celsius. Okay, so this is some basic. And the water boils, water freeze at absolute zero. Okay. So the absolute zero at a Kelvin scale. So the Gay-Lussac is a person to provide the relation between the pressure and the temperature. So after that, based on his law, we designed the constant volume gas thermometer. And also based on this measure, that means they use the different gas to measure the temperature at, and they found that at the, they use, of course, they cannot measure at the temperature of minus 273 degrees. But they use the extrapolation to work out, and they know that all materials will be frozen at the minus 273 Celsius degree, or we call the absolute zero degree at that point. Okay, so the next property, it is the pressure. So the pressure here, it is in presence of force inserted on the surface per unit area. You learned this in the physics subject at the high school. You know that the P, if we call the P here, is the pressure, and the the capital P is the force, and A is the area, and here is the force, and here is the pressure. All right, so the pressure will be equal to the force P divided to the area A. So we got the pressure. Okay, so to measure the pressure, we use the pressure gauge to measure the pressure difference between the absolute pressure of a substance and the atmospheric pressure. Okay, remember that for the pressure gauge, we only can measure the pressure difference. We cannot measure the absolute pressure of that material itself. Okay. For the barometer is the equipment to measure the atmospheric pressure. We call the PKD, that is the atmospheric pressure. And a vacuum meter, it is used to measure the vacuum pressure. We call the PCK. So of course the PCK will be the atmospheric pressure minus the P is the we got the P is the pressure measured by the vacuum meter. And again, for the pressure, we got the different unit. In the thermodynamics, the official unit of the pressure is the Pascal. The Pascals will be equal to the Newton divided by the square meter. Okay, another unit of the pressure we call the bar. So the 1 bar equal to 100,000 Pascal, or is equivalent to 750 millimeter of the mercury. For the atmosphere, for example, we normally say at the normal atmosphere, we got the pressure is 1 atmosphere, so we call that 180. So 180 is equivalent to 9.81 times with 10 had 4 Pascal, and its other units like the bar here, the millimeter of water, millimeter of the mercury. The millimeter of water is equivalent to this Pascal, or the millimeter of water is equivalent to 9.81 Newton per square meter. Okay, so we know that the pressure B, P equal to P divided by the A. For example, we got two guys here. One guy's weight 150 pounds, okay, and this guy's is weight 300 pounds, and both men, the area fit of this both men have areas of the 50 square inch, okay. So you know that the pressure be P divided by A. So in this case, 150 pounds divided by 50, we got the pressure in this case is 3 psi. So psi here stands for power per square inch, okay. In this guy, because his weight is 300 divided by the 50, we got a 6 psi. Okay, so this is about the pressure. And with this principle, you can see in the garage when they want to fix the car, they can move the car up. And of course, the car is very heavy. So how can they just lift up a very heavy car with just a very small equipment, all right? Because they base on this principle, okay? So if we call this one P or F is okay. I think we should use F. It's a mean force is to separate, distinguish with the P, make it easier. So in this case, you can say that of course, the car here, the car here have the pressure of P2, but because the area is the A2, so we use this figure try to make the F1 equal to F2. That means in this case, we can just use a small equipment in order just to lift up a big car and a heavy car because the area is different, okay? So the area is different, that means we can just provide the different force with the same pressure in order to lift up the car. Okay, so when P1 equal to P2, we got F1 over F2 equal to A1 equal to A2. It means we got the proportion between A1 and A2 in order to make sure that the pressure P1 equal to P2 to lift up the car. Okay, all right. So in this example, we got a piston again. In the piston, we got a substand, and in this one, we got the cylinder have the weight of the 60 kilograms, and the area here the 0.04 square meter, and the atmosphere pressure is 0.96 bar on 1 atmosphere. We work out the pressure inside the piston, okay? And you know that this is the force, and the force here equal to the weight and time with the g, and g we call the gravitational acceleration, okay? Okay, so the pressure guard, as you know, that is when the gas go into the pressure guard, it will just move this tube around, and when it's move the tube, it will move the pointer to point at the pressure. You know that this one is just point out to give us the pressure that we want to measure. For the barometer, So the barometer, as you know, that is used to measure the atmospheric pressure. And in this principle, we got the height here is H, the area here is A. Okay, for example, we got a column of the mercury, and the area of the bowl here is B, while the areas of the tube here is A. In this case, we can work out at the 1 millimeter of the water, and you know that it will be the rho times G times H. In this case, rho is a specific weight, or that we call the density. G is gravity acceleration, and H is the height of the column here. And we got this formula in order to work out, and you know that at 1 millimeter of the water will be equivalent to the 9.81 Pascal, because you know that at the 9.81 is a very familiar number. That is the gravitation acceleration. Okay. Another equipment to measure the pressure we call a manometer. So the manometer, in order to measure the different the pressure different by at 2 points of the flow. For example, in the case, you can look at the picture here. In this case, you need to measure the pressure difference between point 1 and point 2. In this case, we use a manometer at 1 point, which is plugged into the point 1, and the second second tube we put in the point number 2. So the difference between these 2 points will be measured by the manometer. Okay. Okay, the third property is we call the specific volume. So the specific volume is a number of cubic meters occupied by 1 kilogram of the particular substance. We got the small v will be capital V divided by G. Okay? Or if we know that the rho here, the density of the substance, we got the small v will be equal to 1 over rho. Okay? So in this case, G is the mass of the substance. The unit is a kilogram. The V, the capital V, is the volume of the substance. Unit is the cubic meter. So in this case, of course, the specific volume will be, the unit will be the cubic meter over kilogram. So as I already mentioned, the specific volume V is the state property, but the big capital V here, that means the volume is not the state property. Okay? For example, we got the volume of the tank, for example, is a 12 cubic meter, and the weight of this tank is a 3 kilogram. So we got the rho will be the m divided by v, that means 3 divided by 12, we got the 0.25 kilogram per cubic meter. For the specific volume V, it will be 4 cubic meter per kilogram. Okay, so that is about the three, we call the 3 basic measurable property of the substance. Now we go into the all three calculated property. First is the internal energy. We use the U. So the internal property is a property that cannot be measured directly. It determined by calculation. Okay? So you know that. Okay? For the internal energy of system, we got consists of the kinetic energy and the potential energy. The kinetic energy due to the motion of the system particles. For example, for the translation, for the rotation, or for the vibration of the particles. It will produce a kinetic. For potential energy, it is due to the intermolecular forces. Okay? So we got the U, that means the internal will be equal to the kinetic UD plus the potential UT. And for 1 kilogram of substance, we got the small u equal to small ud plus small ut. And you know, ud is a kinetic and ut is the potential. All right? And according to the thermodynamic theory, the internal kinetic energy only dependent on the temperature. For the potential energy depending on the average distance between the molecules. Okay? It means it depends on specific volume. All right? But for the ideal gas, okay, you know that the ideal gas defined as the gas that the particle inside it have the very small volume, negligible, and we can ignore it. So in this case, for the ideal gas, the intermolecular forces are zero because there is no interaction between the particle, the molecule inside the ideal gas. So in this case, we can just ignore the V. Therefore, for the ideal gas, the internal energy is only dependent on the temperature. The unit of the internal energy, same as any kind of energy. We got the joule, we got the calories, we got the kilowatt hours. Okay? In the SI system and in the British system, we got the BTU, it stands for the British Thermal Unit. Okay? And again, in the thermodynamics problem, we don't have to determine the absolute value of the internal energy. We just need to determine the difference between the energy. It means we are at the state 1, we move to state 2 here. So we got when the difference between state 1 and state 2, we got the delta U will be E U1 or U2 minus U1. So it means in thermodynamics, we only need to know the difference, the delta U. If not, we don't need to know the U1 and U2 itself. Okay? Okay, next one is the enthalpy H. The enthalpy is a property, again, it cannot be measured directly, determined by calculation. Okay? So the enthalpy of 1 kilogram of the substance is calculated, and we use the H will be equal U plus PV. And you know U here is the internal energy, P is pressure, and the V here the specific volume. So H here will be calculated by 3 other independent properties, which are internal energy, the pressure V, and the specific volume. And again, for the ideal gas, because the U and the PVs only depend on the temperature, so the enthalpy H also only depend on the temperature. And again, similar to the internal energy, the enthalpy, we don't need to determine the absolute value. We just need to know the change of the enthalpy. For example, in this case, we got 2.1 at the state 1 and state 2. State 2, we got the H2. So in this case, delta H equal to H2 minus H1. So it means in the thermodynamics, we only need to know the delta H. We don't need to measure the H2 and H1 itself. Okay? Entropy. So the entropy here is a change in entropy ds of 1 kilogram of substance in the reversible process. Okay? You know that in thermodynamics we got the definition of reversible and the irreversible. So to know about that is a reversible process or irreversible, we need to figure out the entropy. So the entropy ds here will be equal to delta Q divided by the T. In this case, delta Q is the amount of heat transfer in the infinitesimal reversible process, and T is the absolute temperature. And again, because the entropy is a different, is one kind of energy, so the unit it will be the kilojoule per kilogram and a Kelvin degree, or kilocalories over kilogram per kilogram. So in this case, we got the total of the ds equals 0 for any cycle. So if this one is bigger than 0, we got the reversible process. So in case it's smaller than 0, we got the irreversible process. Okay. Okay, that's the property. Okay. So again, properties. We got 6 independent properties. And in order to determine one state of the substance, we need 2 independent properties. Okay? So now we go to consider system not going to change. At this one, all the property can be measured or calculated throughout the entire system, which give us the set of the properties that completely describe the condition or the state. Okay? So it means in a given state, all the property have the fixed value. Okay? And again, we already look at this figure, and you know that we got the state 1, or we call the initial state, and the state 2, and we put in the PV diagram, and one point in that case we got the state. Okay. So it means at the state all the property will have the fixed value and not change. Okay. It means as state 1 here, it got the temperature is T1, pressure is P1, the specific volume is V1, the internal energy U1, and enthalpy H1, and the entropy S1. And at one state, these all properties will have the fixed value. Okay? So when it's moved in the next state, for example, we got state 2, it will have the temperature to T2, pressure P2, specific volume is V2, internal energy U2, enthalpy H2, and entropy has 2. So when it's moved from state 1 to state 2 here, we got the process. Okay? We got the process. So it means any change in the system undergoes from one equilibrium state, or we call the balance state, to another is called the process. And the series of the state in the system, we call the process path. Okay? So I will explain to you. That means when it's going to in a initial state to the final state, here we got the process, and the way it's going we call the process path. For the process, this one I just go quickly because later on we will learn about it later. We will use the prefix iso to designate a process in which the particular property remains constant. For example, we call the isothermal process is the process during which the temperature T remains constant. We call the isobaric process is a process during which the pressure P is remain constant. Or the isochoric or the isometric process is a process during which the volume, the specific volume will remain constant. Okay? Okay, so the next definition is a cycle. So a system is said to have the undergo a cycle if it return to its initial state at the end of the process. That is, for the cycle, the initial and final state are identical. For example, we got the cycle 1, 2, 3, 4, 1 here. So the initial state is a 1 and the final state is also 1. So we make a cycle. Alright? So the cycle, it means we got one round and the final state will be come back to the initial state. Alright, that is about the property, about the state, about the process, about the cycle. We go to the next definition or the next concept, we call the heat and work. As you know that heat and work is two very important objectives of the thermodynamics. So in the thermodynamics, we will work all the system to work out what is the heat and what is the work produced or received by the system. Okay? So the heat and work is very important. Okay, for the heat here, the transfer of energy from one body to another as a result of difference in temperature or a change of phase. You learn it in the heat transfer. You know that when we put the two bodies have the different temperature, and the heat will be transferred from the higher temperature body to the lower temperature body. That means we got the heat. And important, when the object received heat, the heat will be defined as a positive number. Q we use to present it to the heat. So it means when the object receives heat, the Q will be the positive number. And when the object releases heat, the Q will have the negative value. Okay? Work. So the transfer of energy in the application of a force to move the body in a certain direction. You know that force F, this one, force S will be make the weight of the move the distance, for example, we call X. That means force here, when it's moved the, for example, we got the motorbike here, we got the motorbike, and when it moved to point 1 to point 2 here, it make a distance of X, okay, and the weight of the the bicycle here is M. When it moves from point 1 to point 2, it produces a force. Is F is this one, okay. So we call this one is work. And again, when the object produce work, and we use W here to present for the work, okay. So when the object produce work, the work will have the positive value, and when it's have the receive work, the work will have the negative value. And Joule is a person to prove that the heat will be equal to the work, and it is Joule. So that's why the unit of the energy and the work they use at the Joule. All right. Come back of the example of the motorbike. We call that the heat engine. Okay. So later on you will know that for the heat engine it will receive the heat Q1 from the hot source and release the Q2 to the cold sink, and it will produce the work. So of course, because the Q1 is received, so Q1 have the positive value. When the heat released to the cold sink, so we call Q2 is have the negative value. The work, because they produce work, so work here is have the positive value. In case of the refrigeration, or we have the air conditioner, it will receive the heat Q2 from the cold sink, and it will release the Q1 to the hot source, and in this case it receive the work. So in this case Q1 have the negative value because that is the heat release. Q2 have the positive value because the heat is received, and W is negative because this work is received. All right. Okay, just I know you already tired, and maybe you got bored because this one is the first lesson, and the first lesson is always about just the concept and definition. So of course, it's very dry. So sometimes you get bored. Anyway, I try to jump into the last session. It is the ideal gas. So the ideal gas as the hypothetical gas whose molecules occupy negligible space and have no interaction. Okay, so it will mean that the molecules have the very small area or small volume compared with the whole volume, and there's no interaction between the molecules. All right. So in this case, the real gas can be considered as the ideal gas at the low temperature, the low pressure, and the high temperature. Okay. And this equation you already learned at the physics year 11. They call the equation of the ideal gas is the PV equal to RT, or the P capital V will be equal to GRT. In this case, P the absolute pressure, V specific volume, capital V is the volume, T absolute temperature, G is the mass of the gas, and R is a gas constant. Okay. So the gas constant here will be by the Avogadro. We got it. R will be 8,314 divided by the mu. In this case, mu is the weight of the kilogram. For example, the molecular weight of the oxygen is 32 degrees. It means you use 8,314 divided by the 32. Okay, so we work it out, and we got the number of the molecular is m divided by the mu. Okay, so for example, you know this one, you already learned. So anyway, I just move quickly into the end of the lesson. So for the gas mixture, that means the gas mixture by the different kind of the gas, we apply the formula, and by the end we got the Dalton law. It's the pressure of the system of the gas mixture will be equal to the total of the particular pressure of the different gas. That means P equal to P1, P2, P up to Pn. We call the partial pressure. The same, the number of moles gas. So we got the N1, N2, blah blah blah, and C is a number of moles for different gas in the gas mixture. So the total number of moles will be equal to the number of moles for each gas. Okay. And the same thing we can prove that for the weight, we got the total weight will be equal to, here you can see that the total mass of the gas mixture M will be equal to M1 and 2 plus blah 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 up to MC, and then the total mass of the gas mixture. It means, and last we got the volume of the gas mixture will be equal to the volume of each, we call the partial volume. Okay, so that is about the gas mixture. It means the gas combined by the different kind of gas. We got the pressure, we got the volume, we got the weight, we got the number of moles. Okay, and we also can prove that for the density of the gas mixture will be equal to partial density of each gas. Okay, and the same for the specific volume. We got 1 over the V, that means V here, the specific volume of the mixture, will be equal to 1 over in this equation. Okay? And here is a 2 example. You can look by yourself, and here's all the terminology that will help you more clearly about the subject. There is some vocabulary or the terminology that you can have a look in order to help you to understand more clearly the lesson.